What up? It is April 15th, 2018, and it just snowed. What? It's supposed to be springtime. Anyway, Sunday morning, I'm here with Leif in my pajamas. We're chilling. We're designing a pen. What do you think? Good. First prototype finished. Tons I want to change on it, but the mechanism mostly works. You can't watch a show while we're doing this. Click mechanism actually works, although it needs a lot of fine tuning. It gets stuck. It's a little tippy. It's got a zip tie, but totally works. In CAD, I've made a ton of changes already, and my assembly with all the parts where they fit together and slide and everything, I think I'm gonna have to just kill it and start over, because it'll be easier than having all this like garbage and then you delete it all and then start. So kind of disappointed about that because I got really far on the old one, but I can do it better. I've learned a lot. I can do it cleaner, and should be good.
So today we're working on the Saga pen, and today is pocket clip day. I've been kind of putting this off. It's the hardest part of the whole project. Been putting it off till the end. I've kind of been crunching it in my head for weeks now, how I'm going to do it. But yesterday I spent a lot of time working on the fusion model of how I'm going to machine this thing. And here is kind of the model. We're going to machine this on the lathe. And here's the finished simulation of as far as I've gotten so far. But basically we're going to machine this from round bar. The goal will be from titanium, obviously, but we'll make it from brass at first, because as Saunders says, everybody's a hero in brass. It'll be a lot easier to get started. So that's today's project. We got the tooling we need. We got everything. I got the tool paths at least to get started. Let's do it. One thing I do want to mention, I 3D printed this clip like 2 months ago, maybe. It has been super duper handy just to hold it, to be like, okay, so I can think about it and I can hold it, and I can take my little end mills and I can be like, okay, how is that going to work? So to be able to actually have like something in your hand that you can visualize. Everything looks huge on the screen, but when you hold it, you're like, no, that's really weak. I mean, the plastic's not going to be that much different than titanium, you know, with the springiness. So that's been handy. I love my 3D printer. It's actually printing something right now. All right, so far, this is the original prototype, Saga version 1. Eventually, I got to go back and I got to engrave like prototype and a date or something, because I always love that. Then I have my second prototype right here, which I'm much happier about. Differences are, they're basically the same in most components. The tip and the tube are exactly the same. The whole mechanism was fully redesigned, and the tolerances are different and the way they work is different. This one is much softer, and I found it to be too soft. This one has a good firm click to it. Love it. There's still some things I don't like, which I'm changing in CAD right now, but it's coming together really well. And whenever I show this to people now, especially mechanical people, they kind of just, they don't exactly know what to do with it at first, and then they kind of just go, oh wow, oh I like that. So that's the reaction I want always. So, ooh, I like that. So we got a hardened, what do you call this? I think they call it a sure grip. It's an ID expanding collet. So the goal is to machine that down to fit inside there. It's gonna expand and it's gonna be able to hold that. so that it can hold that, we can pull it out, we can do our machining. That's the goal. So one theory I had was to get Hardinge to custom make me a super long version so that I could come in, I could grip on a ring here, and I could also grip on a ring here. But while this black adapter is maybe $100, the quote for the custom one was $500 for a one-off. And I'm like, oh, I don't know if I can stomach that. So I came up with a better way. So right now Angelo's just setting up the lathe, getting some brass in there. We got to get that subcollet in. Yeah, just step by step. You can't rush this stuff, but boy, am I excited. You can get some facial expressions. We'll get Angelo's first impressions here. Significantly better than the first design. The spring, that wave spring that I'm using is too hard. I want it a little bit softer.
Yeah, we'll have some. Yeah, we might have some custom solutions for that.
Yeah,
it works.
But doesn't that feel like way different than the first one?
Yeah, it does. It looks really cool.
Yeah, it does.
Yep. Doing 12 little holes right there.
Just little dimples. Well, you got me thinking about watch stuff now, jerk. So like, but applying that kind of detail to this will be
with a little Grimsmo logo.
Yes, we could.
Yeah.
It's big enough now, right? Like the first one we made wasn't so big.
Yeah, it looks nice. Feels nice. Pretty easy to function.
Yeah.
Use one hand, one finger or two. Bring it down. It's got a nice fidget factor, which is super important.
The sound is right.
Yeah.
Like
a lot of sound.
Like, ready? Sound. This is the Grimsmo sound.
Yep. Yeah, I think we can tweak that with the clip itself, right?
Yeah.
Okay, the distance that we're traveling there. Yeah, that's pretty badass. Very different. Nobody's doing anything like this.
Nope.
Like I can't compare it to the first one because the first one's taken apart now, but the downwards click is significantly improved, whereas the first one was just, it didn't really have a click. And the spring is just a little too hard.
Right.
Could be adjusted, but everything else is great so far.
Sweet.
The mechanism feels perfect.
That deserves a pause.
Yay!
That's nice.
Like the old one wasn't bad, but this is like 150 times better.
Isn't it?
Yeah. Like that's Norseman, like... We don't need a pocket clip, right? They're done? Just
Yep.
good enough? I want one now. That's tight.
Good, yeah.
Home to the mountain.
What do you think?
Beautiful.
Click that bad boy.
Oh my goodness. Thank you.
All right, let's go show Aaron. Knock, knock.
How's it going?
I have to show you something.
Is that finished?
Finished enough.
Oh, wow. Oh, I like the click. That's much smoother. And it feels easier to move, too. And it doesn't feel like it's going to fall apart.
Exactly. Doesn't have a zip tie on it.
Yeah, because before, do you remember I pushed it down like too much or something,
Yep.
and then the
And
thing
it fell
came
apart.
undone, and I
Yeah.
was like, oh geez, I'm sorry, and then I just handed it back to you. That's really sweet though.
Sweet. I'm excited. So I got Kevin here from Elliot Matsura, one of my favorite apps guys. The pocket clip for this pen, for the Saga pen, is going to be a challenge. And this is like tomorrow's project. So I'm really, like, your timing is perfect. Otherwise I would have been calling you tomorrow. So we're trying to figure out how to get C-axis, what do you call it? It's not polar interpolation,
It's cylindrical.
cylindrical interpolation. There's some fancy milling I want to be able to do on this. yeah, and I'm just trying to wrap my head around what the code's going to look like, what the tool paths need to be, what fancy codes I need to apply, and yeah.
So in cylindrical, you have to have each depth of cut is going to be a different diameter that you're at.
Okay.
So you're going to have to stop cylindrical, come out, cancel it, and reapply it to a different diameter. But your cam system should actually post that.
Maybe.
Yeah. I love that kind of stuff. So.
Yep. And actually, I was planning on making it in one orientation, and then Kevin comes in and looks and he's like, well, why don't we make it like this? It's something different. And I'm like, I didn't really think of that yet. So as I'm going through Fusion, trying to figure out the method, I have two options now to like really think about it, which is good. It's going to be a challenge no matter what. I want this to come off of a lathe that makes round parts in one operation. So that'll be fun. I know. Yeah. I know it can be done. It can. It's just like, how much hair do I want to pull out and make it happen?
That's the tough one.
Exactly.
And you will pull your hair out. But once you get it, it's just going to be beautiful, right? It's just going to bang them off.
Can we spit it? Like, there must be a way. Depends on how we hold it on the sub, right?
Correct.
I'm fine making it a semi-manual operation, but man, would it be beautiful if it was just...
Well, there's nothing stopping us. Like, if we did do it, say it this way, there's nothing stopping you, because now you've got it on the manual. There's nothing stopping you from using the same technology that you put here.
Right.
I love this, by the way. Ingenuity is awesome. But coming in with a tool and just kind of pulling it off
totally forgot about
right
that.
into here.
Yep.
So you're going to pull your basket, come over, a little fork, and boom, right into the basket.
Yep.
Yep.
Perfect. I think I saw Jay Pearson do that. Yeah. I mean, use that thing, the opening. You know, have it feed inside and just hit the wall of that and pull it off.
You're right. You actually, your solution is already mounted. Actually,
perfect.
You're perfect because you'll be far enough out.
Yeah.
And even if you had to make a little bit of a slot, right, with your mill on the back side of that ID collet. Yeah, you can come in and pump up against it and pull it right off and it's in there. Yeah. That's awesome. I love that.
Good.
The pill bottle idea is fantastic.
Same original zip tie, year and a half later.
Even if you're not in C-axis on the second spindle, you're going to want to go G496 C1 decimal place. What that does is puts it into a synchronization mode. The C-axes are now synchronized, and you can see that by the flashing.
Oh, look at that.
The right spindle will be flashing.
So this is different than turning, like a transfer.
You can use G496 without the C as a transfer.
Is that what I do normally for the transfer?
You're using M96. It's kind of a...
Okay, that's what I'm thinking of, M96.
It's fine. M96 is kind of the older way to do it. It's very gentle. It's very... There's no real control over it. It's always going to be very, very gentle in the way it speeds up.
Yeah.
Where 496, if you had a big part, you could give it a J value and just say, I don't care, just go. And even if one wasn't completely synced yet, it's going to follow and it'll be fine. But when you're doing smaller parts, the benefit to it is using that J value is you can make it really, really sensitive. So if you were doing like a needle, and one started just a little bit before the second one, you could torque it, right? This way it's going to be even more gentle than M96. M96 works in I would say 99% of the cases.
For milling and everything.
Then you don't have to go and change parameters.
Yeah.
Where G496 it allows you, there's parameters that are set and it allows you to use it in two different ways. But adding that C1 then allows you this capability to, we'll just put a dwell here, right? Just so it's not just continuously spinning.
That's not a dwell. I'm like, that's not a dwell.
X1. And then we'll just say M99, just so you can see that it's going to be running. So now the spindles are actually synchronized in C-axis.
That is so cool.
So even if you wanted to go positive, negative, it will be fine.
Okay.
Yeah.
Excellent.
This is actually a feature that is it's very cool. And And the biggest reason why we like this feature now is one of our competitors had it for a long time, but Fennec wasn't able to do it. So Nakamura, historically, you had to leave the right spindle in basically the turning mode, so it was kind of floppy, right? And if you had two chucks on there and a thin part, when you rotated in rapid, the second chuck would have to catch up, but it also has to slow down, and then it kind of bounces back. I saw it where it was the worst day I've seen it. We were doing a piece of plastic tubing. You could actually see it actually do one of it spring back and forth. So that no longer happens. This is a completely controlled C-axis motion. To get out of it, your code, if you press reset, it'll tell you what you need to do.
496. 497.
Yeah, and that works for both the turning and the milling. So if you go G497,
that's it. No C1 or anything like that. It puts you back
however, if you are in the C1 mode, it will put both spindles, regardless of how you left the right spindle, it will put both spindles into C-axis mode. So you got to come out of that.
Right. Yeah. But they're both still oriented.
They are both still oriented together.
Yeah.
Yes.
But now they're not slaved anymore.
Correct.
So the goal is to bring a lot of these to Blade Show, which is less than a month away. We'll bring some for sure. We've got a production schedule that we're sticking to. Our goal is we did some risk mitigation to see where any risks lie, and you know, we should be able to do this. The big ones will be the clip. It'll just be very difficult to machine, and also the spring we got to figure out. And I don't think anybody's done a machine clip. So not like this. Not like some people do like a bolt-on machine clip. Yeah, a little different. This is a one-piece clip, 3D. We're using a bunch of different techniques to make it, which should be pretty interesting. So yeah, it'll be cool. I'm so excited.
So here we have a clip mid-process. What? So it would normally be held by the subcollet. It would be in there supporting it. I just pulled it back for now because we've broken end mill actually. Broken tool. However, I mean, this is no longer a lathe part. Like, this is a fully milled machined part being made on a lathe. It's ridiculous. It's absolutely blowing my mind, like, not only how capable these machines can be, but how difficult it is to get to this stage. But I'm having a lot of fun. So we made this one here. A lot wrong with this clip, but boy, is it starting to look cool. Had a little crash right there. This big lip is not supposed to be there. But it's coming together. 3D printed some more versions of what it's supposed to look like. Holy moly. Wait, before I show you that. Here's the first one that broke after a couple little bumps and crashes. Here's the second one. You can see a big gouge right there where a tool didn't go the way I wanted it to. There's a big extra lip right there, not supposed to be there. Those two are not supposed to go so fine up there. Anyway, lots of changes, lots of revisions. And then we come to this guy. What? I am so relatively pleased with this. So the pen project is coming along great. It's called the Saga, S-A-G-A, as in write your saga. Very Norwegian word. I thought it was awesome. Coming along great. The clips are kicking my butt, but they're making progress. They're coming along, so I can't wait to do that. The goal is still to bring some to Blade Show. We'll see. I still got to order a lot of parts. Still got a lot of work ahead of me. But this is like my Blade Show crunch. That's some, you know, every year we always tend to find something to crunch before Blade Show. Luckily the knives are completely ready for Blade Show, so that's not a worry anymore. So that's good. Yeah, thanks for watching, guys. We will keep doing more pen videos throughout the process. They'll probably be like Saga Saturdays or something. And yeah, stay tuned for more. Thanks, bye.